Tonight's objective is I can find the surface area of a three-dimensional figure made up of polygon faces. And our focus for tonight is going to be triangular prisms. So this will be a review from 6th grade math. First of all, let's remember what a triangular prism is. A prism is named by the shape of its bases. In a prism, there will be two parallel bases. You can see the one on the front, the one on the back. Obviously, we can't see as well because it's hidden back here, but there's another triangular face in the back that matches the one up front. And those are the bases of our prism. All other faces on the prism will be rectangles. So there's going to be 3 rectangular faces. Those are sometimes called our lateral faces. So for a triangular prism, you're going to have triangular bases on the front and back, and then you'll have 3 rectangular faces. What we're going to do tonight is we're going to review finding the surface area of a triangular prism, which is just finding the area of every surface that makes up the outer coating of that triangular prism. So it's going to be a matter of finding the area of the triangle at the front and the back, and then the 3 rectangles that make up the triangular prism. We'll add up all those areas. That'll be the total surface area of the triangular prism. So here's a couple of diagrams. It says find the area of the following figure. This figure is a net of a triangular prism. So I went ahead and I have the net up top. Triangular prism is made up of 2 triangular faces that will exactly match, and then 3 rectangular faces. If we fold it up, it'll look like this. And so I'm going to start by finding the surface area using the net, the area of all the faces when we add them up. But in our next example, we're going to focus on a triangular prism that's put together as a 3-dimensional figure, and we're going to have to be able to recognize the dimensions of each face. So we'll try that next. But for now, let's just go ahead, and I can even call it figure A and figure D. Those are going to match. If I look at figure A and figure D, those are our triangles. We're going to have 2 of those. And we know the area of our triangles is 1/2 base times height. Sorry about that. And so then we would have 1/2, the base of our triangle would be 10. And the height of our triangles have to meet that base at a right angle. So they show us the height is 12. So we have 1/2 times 10 times 12 is 120. 1/2 of 120 is 60. So that would be 60 square inches for each one of those triangular faces. There's 2 of them. So I have to do 2 times 60, or 120 square inches for our 2 triangular bases. Now we have our rectangles. One of our rectangles is the area of figure C. And for figure C, the area of a rectangle is base times height. Oops. Sorry about that. Base times height. So let's see what the base of figure C is and what the height is. Well, it looks like the base of figure C is 18, and it looks like the height is 13. So 18 times 13, let's go ahead and find that. 18 times 13 is 234. Sorry, that should be a 13. So that's 234 square inches. And if you look also at figure B happens to also have a base of 18 and a height of 13. So that area would also be 18 times 13. So we're going to do 2 times 234 to get the total area for C and B. So let's multiply 2 times that. That'll be 468. So that'll be 468 square inches. Now I have to go ahead and find figure D. We're going to find the area of figure D. Figure D also happens to be a rectangle. We're going to take the base times the height of figure D. The base is 18 and the height is 10. So this will be 18 times 10 for the area of that rectangle, rectangle E. So that's going to be 18 times 10, which is 180 square inches. Then to find our total surface area, we have to add up the area of all our surfaces. So we take the area of our two triangles, which we found was 120 square inches. We take the area of the two rectangles that happen to match, which was 468 square inches. And then we finally take our last area for figure, that was E. That should have been figure E. The middle one was figure E. Is 180 square inches. We just add those all up. That gives us our total surface area. 120 plus 468 plus 180 is 768. So 768 square inches is the total surface area of this triangular prism. You can look at it as a net, or we could break it down as the actual triangular prism. In the next example, I'll have different dimensions, but the net isn't given. The actual triangular prism is given. So it says, find the surface area of the following right triangular prism. Please note the base of the prism is a triangle, so there'll be two triangular faces, and those will actually match. And it says additional figures have been provided to highlight the faces. Okay, let's find the area of the top triangular face and the bottom triangular face. Well, our triangular faces will match. So when we find the area of the top triangular face, the bottom triangular face is going to match. So that would be area equals 1/2 the base of the triangle times the height of the triangle. It's important to remember the base and height of a figure have to meet at a right angle. So this 12 has nothing to do with the base or the height. For your triangles, the base can be 7.5 millimeters. The height would be your 10 millimeters. So this is 1/2 times 7.5 times 10. And the bottom has to match it. So we can close that figure off. 1/2 times 7.5 times 10, if you want to show work for both. So let's do 1/2 times 7.5. That's 3.75. Half of 7.5 is 3.75. Then we'll multiply that by 10. So it looks like 37.5 square millimeters, or millimeters squared. So again, when we multiply this other one out, it'll be 37.5 millimeters squared. So if we want to find the area of both of those faces together, we could always just multiply 2 by 37.5, and you'll get 75. So that's 75 millimeters squared for the triangular faces. Those are the areas of your triangular faces, which will be the bases of your triangular prism. So now we have to find the lateral faces, the areas of the lateral faces, which are all rectangles. Okay, so we have to remember for our triangular faces, the total area was 75 millimeters squared. I'm going to need that back, so I don't want to lose it. So let's find the area of the first lateral face. We can choose any lateral face we want. I'm going to choose this lateral face. So I'm just going to outline this lateral face right here. And for this lateral face, I need to know the length and width, or base and height, of this lateral face here. Well, I can see the height is 15. Area equals base times height. I can see the height is 15. What's the length of this base? What's the length of that base? Oh, it's 12.5. 12.5 millimeters. Okay? So if you look at the front, it's 12.5 by 15. So that's 12.5 times 15. 12, oops, sorry about that, I jumped a slide. 12.5 times 15 is 187.5. So that rectangle is 187.5 millimeters squared. All right, let's take a look at another one of the rectangles. I'm now going to outline this rectangular face. You have to be able to see the three different rectangular faces. So now here I say, okay, what are the dimensions of this rectangular face? Well, I gave you extra pictures so that you could physically outline, and you'll be able to see, oh, for this rectangular face, it's 10 by 15. So the area of that rectangle too, base times height, is 10 times 15. That will be 150 millimeters squared. All right, so now we have the triangular faces being 75 millimeters squared. We have rectangle 1 being 187.5 millimeters squared, and rectangle 2 being 150 millimeters squared. Let's figure out for rectangle 3. I better write these all down. Total surface area for my triangles is 75 millimeters squared. We had 187.5 millimeters squared for one of the rectangles, and we had 150 millimeters squared for the other rectangle. Now we got a third rectangle. We haven't yet calculated the area of this rectangle. So now we have to see on this rectangle, what are the dimensions? Well, if I look here, I can tell you the dimension here is 7.5, so this dimension here is 7.5. If you see this 15 here, if I slid that 15 up, that height is still 15. So the area here, base times height, is 7.5 times 15. And what's 7.5 times 15? 112.5. So the area of this final third rectangle here is 112.5 millimeters squared. So to find the area total, we simply add up the area of both our triangles and our three rectangles, and that'll give us our total surface area. So 112.5 plus 150 plus 187.5 plus 75, that's 525 millimeters squared. That's the total surface area of this triangular prism. Hopefully that's a little bit of a review from last year about finding the surface area for a, hopefully I said triangular prism a minute ago, that's what I meant, for a triangular prism. Tomorrow night, we'll focus on rectangular prisms. All right, try to have a good night. Take care.